I'm starting kind of early. I mean, it's 3 minutes early, so I just figured to say, hey, how's it going, guys? 4 people are currently here. I saw 7 at one point, but maybe they went to go run and get their stuff. Um, so in case people are wondering, you do need a battery, preferably with a wire connector. By preferably, you really need it unless you just have wires. You also want to make sure you have in your possession some resistors. We'll talk about like resistor color coding and such. You also want to have a multimeter. I have a couple multimeters, so I can try different ones depending on which one you guys have. This is a standard basic one. You will also need a breadboard, which is this. Literally called a breadboard because it was originally made using a breadboard. Let's see. No, that's pretty much all you're going to really need. You'll want some space to do them. You also want your SDLs, which I just buried under some crap, so I'm going to go grab those. A little bit more sparse then. I guess I didn't tell you guys early enough. Please, if you are here, if you could comment, I'm trying to figure out who's actually here. Additionally, if someone you think is going to come on this, if you could please text them, call them, what have you, let them know we are doing this, or at least definitely tell them they should watch this one. Looks like everyone who's here tends to be a bit quiet. Maybe I'm quiet. Everyone can hear me? Who's here? No, maybe. Doesn't that open yet? Okay, cool. Just checking. Thanks. Yesterday, you guys were a lot more talkative. And I'm still trying to figure out how this works. So, all right. Thank you guys. Cool. We got our group. All right. So I'm going to start off with just some quick announcements. So, yeah, you guys are shy today. All my loud mouths for yesterday. So for announcements, Google Classroom, I'm going to be making some changes. I already talked to Ashley today. Yeah, you're probably right, Navi. I talked to Ashley today. I'm going to be splitting up the Google Classroom. This doesn't mean you can't still talk to each other on the old Google Classroom, but for grading purposes, having 2 periods at the same time is extremely complicated. So I'm actually going to be breaking up the Google Classroom into section 1 and section 2, or period 1 and period 2. So I'll be providing that information later. I don't want to do it right now. Hi again, Ashley. I don't want to do it right now because I know there's some assignments you guys are turning in. So please turn in everything by Friday. Saturday, I'll post all the new information for the new Google Classroom and get everyone signed up and split up. This will make it easier for me to form groups and all those other things that we're apparently now have to do while not being able to see each other. So that's first. 2, the quiz on College Board should be up. It is going to be open from 9 a.m. today, so it is open to 8 p.m. So please finish that. After that, you're going to be locked out. Alana, I am thinking about getting rid of the one we have now, or at least later archiving it. I'll give you guys time, but all new things will be posted on the new ones just so we can separate it out. And I'm going to try to organize it better just because I know the current one's kind of just thrown together because I didn't really need it. It was just like a backup. Now it's the main thing. So I'm going to try to make it a little more formal, a little easier to organize, set up materials and that sort of thing. So I'm going to spend the weekend doing that. So yeah, and I'll try to give you guys a chance to get anything you need off the old one. And I'm going to be transferring a lot of it over to the new ones so that you won't hopefully lose anything major. So again, as the quiz, it's on collegeboard.com. I did provide a link. This would be the same place that you signed up for the AP test in September, October. So you want to go back and check that sometime today. We're probably going to do some basic quizzing on here. It seems like a pretty easy format to use, possibly do tests on it just so we can do feedback. As such, this is such a crazy time. I'm going to be extremely lenient as long as you're kind of following along. I just want to check in with you guys, hear from you. The quiz is only on waves. So it's just to kind of do because we're done with waves. We luckily pretty much finished that by the end. I was gonna do like maybe 1 or 2 days of like wrap up. Um, so the quiz is just so I can get a checkup of like what are we good at, can give you a checkup on if you're like, oh, these are the things I'm struggling with. I'll be posting some review based documents from 5 steps to a five. Again, probably this weekend on the new classroom, which is why if some of you are like, why hasn't she posted anything? I was holding back while I was making my decision about whether or not I'm going to split up the class. And I ultimately have, and I'm going to do the same thing for regular physics. All those classes are going to be split up via sections. You'll get all the same stuff. So if you work with someone from a different section, it's not going to be any different. It's the same exact material. Um, Tomorrow, I'm going to make an attempt at Zoom because people are saying it's more interactive. It's good. So we'll try it. We're trying things right now. So I'm going to be setting up a Zoom tomorrow at 1 p.m. I'm going to post more details as I figure it out tonight and tomorrow morning. But keep aware that at 1 p.m. tomorrow, I'll be doing another kind of live chat, probably going over the lab and the quiz, which hopefully you all will have turned in, and I'll have time to look at the data and figure out where do we need help, where do we need remediation. Also, the goal for that is to do some circuit problem solving together. Hopefully, you'll have a little bit of lab experience by that time, and then we'll kind of work through how to actually solve the problems mathematically. But I want us to actually get a good intuitive understanding of this so that you're not always like, oh, the math, because on the AP test and in real life, they don't normally are like, here's a calculator, here's a pencil, go. You just gotta think about it and be like, oh, this is how it works. Um, but yeah, so the Zoom maybe is how we'll try to conduct like a normal class. We'll see. All right. So I'm gonna actually teach us about resistors and color coding. So color coding goes as this. So if you have a little resistor, come and like look at it. Unfortunately, I'll use a big one, but I know the little ones are this tiny and extremely hard to read. But basically, there are 4 or 5 color bands. Sometimes the fourth one isn't there, or excuse me, the third one. And so, for example, this has its 1, 2, and 4th band and the 5th band. And so what it is the first color is just the first number. And it goes black, brown, red, orange, yellow, green, blue, purple. There's technically gray and white after this. None of the resistors I gave you have gray and white. So if you see gray and white, look a little closer. And so they're just all 1, 2, 3, 4, 5, 6, 7, 8, 9. This is just so they're not going to write tiny numbers on here. Numbers wipe off. They do color codes only. And so you would read, for example, this one is brown, green, red, space, red. So I'll write that up here. So the resistor I have is brown, green, red. And so what this corresponds to, and then if you have the tiny ones, all of them are 5s. But what this corresponds to is a number. This is 1, 2, 4, and 5. And so the last one I really don't want you guys to worry about. It's just this 5th band is the tolerant. It's often the thickest one is what they try to do. It doesn't always show up, but this is just how much they can take. So how much voltage they can take, how strong they are. The reason why I gave you extremely strong ones is so that they do not get overblown or overheated, and then the resistance changes. So it's just how much they can take. All of yours should have a brown color band for the little tiny blue ones I gave out. If you have any of these ones, they also 1% is kind of standard. But it's not a huge deal. The ones you really want to look at are the first 3 or 4. So 1 and 2 are literally the numbers. So this would be 1, 5, and you can think of this is a multiplier. So black is times 1, times 10, times 100. And if you're like, how did they correspond these? This is 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3. So that's 3, 2, 1, and so forth. So this means 1 or 15 times 10 to the second, or 100. Or as I like to think about it, how many zeros you put after it. So these are your numbers, and I'm going to put, it's a red, I'm going to put 2 zeros, so 1500. This means this is 1,500 ohms. So I'll put up another one. And so what I would like you guys to start trying to do is identify each one of these. So you only really have to deal with 3, so you only have to memorize 3 color bands, or whichever color bands yours are. So I want you to look at yours and try to identify and post in the comments, because I know which ones are realistic and which ones aren't based on what you have, which color codes you have. Colorblind or not, there's only a certain number of colors you can get. There are no, well, there's a couple purple on your guys's, but there's actually no blues. There are no blues in any of these because just of the numbers on them. There are very, very little oranges. If you have a yellow and a purple band, it's probably yellow-purple because it's 47 is a pretty standard number on this set. So go ahead, try to figure out what yours are. I'm going to do another one if you're totally not sure. So this one's hard to see, but it's actually brown, black, black, yellow, space brown. So either way, you might be wondering which way. I know these. There's no way it's 400. There are no 400s in this set. So I know that the first number cannot be 4. There's 47s, but no 400s. Not entirely sure why, but I think it seems to be standard. I've seen it at a lot of places. So again, this one was brown, yellow, black, black, brown. So I'm not going to worry about the last one, but brown, yellow. So it was brown, yellow, black, black, brown. God, it's annoying dealing with all these pens. I miss my fancy pen. Whatever. So it's brown, yellow, black, 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 brown, which gives us brown. If the first number is just a 1. For the yellow, it's a 4. And then 0, 0, or excuse me, 0. And this last one is the 4th one, which is a multiplier. And so when I look at that times 0, 140, I also know there's no 140s in this pack, so I'm going to flip it. Which is why I'd love for you guys to post which ones you think you are, because I can definitely knock out some of those. And so that needs to be 100 times 10 to the 4th, or put 1, 2, 3, 4 zeros after. So this is a 1 million ohm resistor, or more accurately, a 1,000 kilo ohm resistor, because that's how I would like you guys to write yours. So right now, and if you want, you can send me a picture on Remind right now if you have no idea what to do about your resistor. They do look very similar. There's also things you can do like online services. Actually, let me search one up where you can just type in color bands and it will tell you. So they have little calculators for you. Where is one? Let's see. And so you don't really want to worry. You can do 5 bands. Let's see. There we go. And so if you do not want to learn to memorize these, you don't really have to. Right, I just posted a link that if you can just put in the colors, it should pop some out. So please, please start giving me some so I can start telling you like which ones are possible and which are not possible. Um, so as far as possibilities, I'm gonna erase this because I did just put out the color code and it has lists and there's lists online, and I do need the space. Um, Oops, too bad. So, has anyone tried looking at their color codes? Anyway, some of the common ones, yeah, they definitely have. I have 100,000. So those are common. So here are the common things you're gonna see. They should be like 1,000 or 100,000 or 10,000. Those are pretty common ones. You'll get 220 times 10 to the whatever, 1 times 10 to the something. But they all end up being around. And I think I have some 1.5s out there. They're a little less common. But your starting numbers should be one of these four starting numbers. 47, 2.2. Yeah, those make sense to me. And so that's kind of what you're looking for. If you get something that's wildly different, I would just look at it, flip it, and get it to the other side, and you will theoretically probably get some of these. And so, do you guys want some time before I move on so you can kind of figure out what yours are? Do you want me just to keep going and you can pause it and keep watching semi live later? Which would you guys prefer? Please post in the comments. Trying to tailor make this the best we can. Because next we're going to get into wiring, which is going to be hard to show. I'm going to use the big ones just so it's a little easier to show. Keep going. Time, please. Oh, good. We're split decision. How about this? I'll give you like 2 minutes and I'll pull out the rat for people who are bored. How about that? Does that work for people? I'll go walk, grab the rat, move her location, wake her up. So, okay, got it. All right, so I am back. Plant succulent collection. My house is a mess, but I will clean and show you guys another time. Ashley won the giveaway today. She got some plants for her house because I don't have space to bring back plants from the classroom, but can't tell if it's red or orange. Alex, I highly bet you that it's red. There's not a whole lot of orange in these. If it's a multiplier, it could be orange, but it's most likely not. Yeah, 47K. I definitely have 47K. Um, so yeah, and so just at the some people have already done basic circuits, especially anyone in robotics or electronics classes. So um, yeah, so yeah, this is Zora. She's the remaining one. We had 3 rats. She's actually our 7th rat, but of her group, she had 2 sisters who have since passed away. 1 million. Yep, I have 1 millions. I think I have a 1 million out right now. Um, so yeah, yeah, Navi, or if you work with your dad. Yep, there's a lot of. I never did circus with my dad, but my brother did. So, can you do a rat giveaway? No. If you ever want to adopt a rat, you're welcome to let me know, and I can provide you a wealth of information, possibly a starter cage, because she's probably going to be our last rat. Um, just because we have a bad infection in our colony. She actually gets medicine every single day, every morning we make it for her. So she's a very special rat. It's also probably why she's fat because we give it with food. 13K. I do not have a 13K, Jan. I would flip it around. Um, my mom will kick me out of the house. Yeah, my parents were like, "Why do you have a rat? It's a vermin." And I'm like, but I don't live with them anymore, so I can do what I want. Um, yeah, that my uncle once owned a tarantula, and my grandmother almost hit him with a hammer. The only reason she didn't is he was faster. So, so I definitely get you on the certain pets are not allowed at home. Does she bite? No, she does not bite. Well, unless you have food on your finger, in which case she'll bite your finger, bring it close, lick the food off, and then let you have your finger back. But she can hold on pretty tight if she wants to. If a rat ever bites you, it's either one, afraid, or two, thinks your hand is food. So you normally wash your hands first. Are some of the lines thicker, Alex? They should be. I don't know if they are, and these were kind of a cheap set I bought on Amazon. So again, if you get one that I'm like, I don't think so, just flip it the other way and try to reread it. Again, it should be either 1/2247 or 1.5s in that set. I'm actually surprised New Dog is very passed out. New Dog is a little too interested in the rat. I don't think she wants to eat it, but I think she wants to play with it. But that would probably be deadly, so we're not going to do that. All right, so hopefully, regardless of if you know your exact numbers or not, you can always send me remind pictures of them and I can help you identify. Just try to send a very clear picture. I am going to move on to wiring. So, regardless of if you know, you want to go down, honey? Okay. Regardless on if you know your actual numbers or not, close up, and I'm going to send her back home. Keep the rat. No. That was actually her sign that she needs to go to the bathroom, so I'm going to let her do that. So what you're going to want now is your breadboard. So this, and we're going to show you how to actually wire it. So for ease of carrying, I'm going to detach my battery just because I actually have to hold these things. I can't put them on a table to show you guys. And so you're going to want to you have a red end and a black end. And if you've ever worked with circuits before, the red end is a positive and the black end is supposed to be negative. Does it actually matter a whole lot? No, not with what we're doing, but it's if you ever want to hook up your car battery, it's very important you put these on the right ones. So the red one goes into the positive sign. Yours should have a positive and negative. I like to put them on opposite sides. It's not really important. It just helps from getting your stuff tangled. And so your first step is just hooking those up correctly. So positive end, negative end. After that, we want to hook up two in series. So hopefully you guys do have your SDL. You will need that battery. If you don't have it right now, it's fine. I'm not requiring the labs right now. I'll also be making, you are supposed to have that, Alex. If you don't have that, I'm making like a Christmas run tomorrow. Oh, I never actually mentioned that. I'm basically being an AP Physics Santa, but I'm not coming down the chimney and I do need your address. So if you need supplies, make sure you let me know. I'm going to go on a battery run to Home Depot today. I'm going to possibly buy more multimeters. If you have the money to refund me, you're welcome to. But otherwise, I'll try to hit up Whitmire for money when I have a chance. And so even if you didn't bring all of these specific things, positive is red, negative is black. Either from me, they're extremely cheap. If you lose these, I'm not particularly worried. But for this wire thing, I will drop this off. I do have some multimeters. I'm again going to buy some. So don't put your requests in here because I'm not going to come and look at this. But I will be walking around dropping stuff. You cannot use a normal AA battery for these. It's not going to be powerful enough. What is the wire thing called? Great question. It's called I think it's called just a battery holder. I have plenty of these. So again, I'll how about this? I'll make a form on Google Classroom that will just be used for this where you don't have to fill out and it's just what do you need? I'll have a list like check, check, check. Creepily, your address because I need to know where you live to drop stuff off. And I will be making a run tomorrow morning and just drop stuff off like Amazon in front of your door. I'll knock, but I don't really want to wake anyone up in case I go early. So please withhold anything about like, oh, I need that, I need that. Um, but do keep, yeah, I can't help you with toilet paper. I'm not bringing the rat. She doesn't enjoy car rides. She actually doesn't mind them, but it's just an extra thing. I don't want her to get too cold when she already has upper respiratory problems. Um, so this is just the wire holder. And so again, black goes in the blue, red goes in the red, and you color code it. So I'm doing the first lab here. So if you don't have your lab out, please bring your lab out. If you don't have that, I can also bring that, although hopefully you did grab papers. So this is what you want to have out. So we're going to just do number 1. I'll show you how to wire it. And we're going to have a larger and a smaller resistor. So theoretically, as long as you're not using the smaller resistors, it doesn't really matter which one you use. There's going to be a larger and a smaller. And so I have right here, this is my 1.5. And this is my 1000. And so I want to wire these in series. So we're going to go over series more hopefully on the Zoom broadcast tomorrow. But we can see that they're in series because there's only one line, one path for the electron to travel. So it's one after another in series, just like when you watch a TV series, it's one episode right after another. And so we're going to wire them in series. So we're going to show you how to wire this through this. I'm going to walk you through the questions and what I want here. And then if you have a chance and you have the materials, test it. If you don't, I'll be, dropping hopefully things off at your doorstep tomorrow. And or FaceTime a partner if you don't have anything else to work with. I've set a budget cap on how much I'm willing to spend on this class of my own money. So we'll see how much I can get with that budget cap. So you're going to want to connect one side to one side of the battery. And so you want to make sure these line up. I have to put it down to put these in. All right. And so I lined up with the negative side. You don't have to do it with the negative side first. I just did because ultimately, and you can see how it runs along this blue line. This no, you don't need to know the number. It's fine. For right now, I just want to show you how to wire it. We'll figure out the number in a second later. But anything along this blue line right here is all connected. Ashley, if you can, if I'm giving you, it'd be nice, but it is no way necessary. I actually am still earning a paycheck, so, I do have money and not everyone is that lucky at this time. So right here, this blue line, all of these are connected. And then I'm going to put this, it can go anywhere. It doesn't really matter, but I'm just going to put it in some empty block. The thing that does matter is now these blocks, these are all done vertically. These are all connected horizontally. So I want something that's on this same line. For me, it's number 20. So I want something else that's along the line at number 20 so that they can hold hands. And so I'm going to place my next resistor in this hole. So I go from one side of the battery to my resistor, over to my other battery to my resistor, and then I need to finish the circuit. So, Whitmire is already having enough issues at the moment right now trying to manage a whole school. And so my last one is going to go right here in the red. And so that when I connect a battery, and then make sure you stick it in there. You should kind of feel a little bit of resistance and then kind of a give. Oops, I got that stuck in there. It doesn't really matter. And so hopefully you can see that we went from one side of the battery, negative, to a resistor, holding hands with another resistor, back to the positive side of the battery. And so if I put a battery right here, I'll complete the circuit and I'll have charge flowing. No, this will not shock you. And even if it's 9 volts, 9 volts is really not going to do anything to you. You have way too much resistance to get a lot of amperage or current going through you. And so this would be the basics of wiring it. So go ahead, take a second to try to do that. I'm going to connect my battery. Do they have to be in the same hole? No, you in fact cannot put 2 resistors in the same hole. It will break. So these are close. They're in the same row, but not in the same hole. So they just want to be in the same row so that they connect. Where is the light bulbs? I do not use the light bulbs for these. They're extremely hard to shove into those tiny little pieces. So you really want to be using resistors here. Also, light bulbs are not ohmic. And we'll talk more about what that means, but they're basically not going to be good for experiments because they are non-ohmic resistors. And so what you want to do is once you have this, then you want to try to get your multimeter. So once this is set up, I'm going to disconnect it so that I don't run my battery for no reason. And so then you want to get your multimeter. And so your multimeter could look a couple different ways. This is one of the versions I'm giving out. I have another fat version. And I have these. They're my old reliables. But basically, you want to turn it to the voltage, preferably the 20 volts. So either it says just a V with the straight lines, no squiggle lines, that's alternating current. We're only going to do direct current. So you want to find the V on your device with a straight line and turn it to the 20. For a lot of you guys, I did this before I gave them to you just because I know sometimes it's hard to find the button. It's the same thing. This one's also set to 20. And the reason we want to do 20 volts, it's just like if you have a measuring cup, you don't use a 1 cup measuring cup to try to measure out 4 cups of things. You would say step it up a notch and use the 8 cup if you want to measure 4 cups. And so we just want it to be a little bit bigger than the voltage of our maximum voltage or the voltage of our battery. Since we're using a 9 volt battery, 20 volts is plenty. Yeah, it says DCV, yeah, so direct current voltage. So it'll either say V with a straight line or DCV. Both are good. Those both mean direct current. So it's just whether they decide to do an acronym or do the symbols. And so this one doesn't say doesn't do the acronym. This one does. This one has symbols. This one does not. Doesn't matter. It will get you the same thing. And then once you're here, the way that you measure, I'm going to try to awkwardly tip it DC. It should be about ADC. ADC. No, ADC is the current. So you do not want to be measuring the current. That's in fact the only way to hurt these. So make sure you're on the right setting and some have them color coded, like the yellow and the white are different things. So basically, the only way you can blow this, what is even a current, it's how much electrons flow through it. And we'll get to it a little more. Make sure you're watching your homework videos explaining it. I'll probably do a lesson on what is current, what is voltage, and so forth. I kind of just want you guys to play around with it because you'll learn quite a bit on how things work just by being like, well, what happens now? What happens now? And I can't be there to directly tell you things. So you want to make sure it's on the voltage. If you are on anything that says A, if there's an A involved, that is not the right place. So voltage is how much energy per charge. Current is how fast is the charge moving. So it's whether or not it's measuring how much energy is behind each charge or how fast the charges are going by. If you try to measure how fast they're going with something that measures how powerful they're going, it's not going to work, and vice versa. The difference is, though, if you try to measure voltage and you're on the current setting, the current readers are very sensitive. And so you'll blow the current reader and essentially disable the entire multimeter. Voltage measurements will probably still work, but it will no longer measure current. If you have one of these are brand new and have never been used. These probably their current meter is already broken, so it doesn't really matter. You just won't get the information you wanted. And so when you do this, you are doing voltage. So you're going to hold, to measure voltage, you're going to hold in parallel. So you're going to want both hands touching your battery or both hands touching the resistor. So if I want to measure the entire voltage of the whole battery, I'm going to tilt this down and see how it goes. Not great, but we'll work with it. Okay. So my battery is now connected. So I just connected both sides of my battery, or I'm about to. And so if can I prop this up? Not very visible, but we'll work with it. So if I prop this up and I touch my battery over here, and we can see that I get a reading. And so I'm holding both hands of my battery. By both hands, I mean both sides. It's coming out positive, which means I put my hands on the right ones. If it comes out negative, all it just means is you switch which ones are where. And so we'll notice that this is not an entirely full battery. It should be reading at 9 volts. It's only reading at about 8.1. So it's dying, which is fine. It's what I expected. And then what you want to do for your lab is you're going to measure each one. And so for mine, I can see that one of them, this is my 1000, is giving me 3.5 volts. And this one is giving me 4.8 volts. And so if we add those up, that's where we'll get our original, our original 8.1 volts. And so that kind of proves what we were talking about yesterday, how even though they're going to get different voltage, it's still going to add up to the total because they're in series. That's one of your big rules. So if you didn't get that one, I would replay it later. I'll be going over things additionally over Zoom, as well as doing little remediations. But the main thing is hold hands with them. So whenever you're measuring, you want to hold hands with them. And what I mean by hold hands is you're going to touch both sides, one with each side of this. No, and I can't do it very easily on camera. But you're going to hold, this is one resistor, and if I want to measure the other resistor, I'll hold the other hand. And so you want to hold both hands when you're measuring voltage. We're not going to bother with measuring current because it's pretty finicky and a lot more annoying to do. So you're just going to be measuring the voltage. All right, that being said, let's take a look at your actual lab. And then make sure you turn these off. Most you have to flip to off. If you don't, it will die much faster than it would if you hadn't. All right, so key things with this. Make sure you finish this before you go to the next one. It's extremely important to your overall learning, especially because I'm not there to support. But basically the idea is through doing this, you're predicting what's going to happen, testing results. New but similar circuit, test, predict, test, predict, test, predict, test. So the first question on here is which resistor has a larger current through it and why? Think about it to yourself. Talk to the people around you, i.e. FaceTime them, call them, text them. I'm going to go do something, maybe get tea. My throat's getting sore. I'm not getting sick. It's just rare that I talk for 38 minutes in a row. So try to answer the first questions A, B, and C. So go ahead, talk about it, post your ideas. Feel free to look up any physics facts. There are circuit facts in your packet. I may post a separate circuits only fact sheet just so you can easily find it on the website. But go ahead and look this up and attempt to answer which ones A, B, and C. And we'll talk about it a little, but I really want you guys to test it on your own and then feel free to send in your answers, and I'll have ways for you to submit answers in the new Google Classroom starting next week. So I'm going to go get some water and I will be back. Okay, so what do we think? Seriously, if you guys don't post anything, I will not help you and I will sign off for the day. So post your predictions. And so again, about the first question, the current, it's asking which one's going to have a bigger flow through it. Hello, dogs. No predictions. Which one's going to have more flow going through it? This one actually doesn't have to do with Ohm's law. It has to do with the junction rule. Oh, are you trying to look up in the fact sheet? It should probably be under series or it should be under series, if I remember correctly. Okay, so Eduardo's making a lot of predictions. And in fact, has made 5 comments to no one's. Come on, people, be brave. No one's really judging you. Well, or at least they shouldn't be. All right, wouldn't it be the larger one that you're using Google? You can use Google, but Google often leads astray, so just be careful. At this point, I really don't care how you guys are learning. I care that you're learning, because this is a odd and difficult situation. All right, so we said 1 for the 2 for the larger. Okay, 1 for the same, 1 for the smaller. All right, that's 5 votes out of 19 people watching. Okay, yeah, I got you. It just said the understood from context. All right, so we have a lot of options. 1, the answer is definitely in there. But the short version is, once you've predicted, and so more importantly, you want to think, well, which one's going to have more voltage going across it as well? And so what you want to do is predict the voltages and the currents. The resistors you shouldn't have to predict. You should look up and know. So what do I say, Eduardo? I'm not going to say anything. I totally want you guys to predict this and figure out what the heck happened. For these, well, maybe I'll give you the first one. They're in series, which means current is how many electrons go through. If I have 10 electrons come from the battery, how many electrons are going to go back into the battery? Okay, Catalina, I'll look at it in a second. So if I have 10 electrons leave home from the battery, how many electrons go home to the battery? All 10. They're just tired. So, oops, that's too larger. So all 10 go home. So if I have an electron leave home, he goes all the way around and he comes back. You do not destroy electrons. You use up their power. They're essentially your little electricity slaves. Like you make them do your work for you. That's how we've harnessed and controlled electricity and created the entire foundation of Earth and so on. But so we have a little electron and it goes through the whole way and comes back. Remember, we're going to have like tons of these electrons, but as many leave home, that's the amount that come back. You don't destroy it. You conserve matter, you conserve energy, and you conserve charge. So electrons have mass and charge. They don't disappear. They just are less powerful. They're tired by the time they get home. And so a basic rule is if they're in series, it's always the same current if they're in series. You can't kidnap something from a wire, Eduardo, then you're making it a parallel, and in parallel, the current does. Yes, they have 0 volts, so current and volts are completely different. So current is how many of them are. Voltage is how much energy they have. So here's my little analogy. So you are driving home. You're going to make it home. No one's dying along the way. It's not that kind of story. You're driving home, you have so much energy. There are so many cars on the road, and they're still going to be there, and you're all going to make it home. But however much energy you have when you started out the day, you were probably dead tired by the end of it. You lost the energy. You still exist. You're just done. You're tired. You're ready to go home. So they're going to have 0 volts, zero energy when they get home, but they're still getting home. They all still go. So let's say I have 3 electrons leave home. I'm going to have 3 electrons make it home. These electrons are going to be very excited. They're all going to start with 9 volts, going to be very energetic, so ready to go. And later, they're going to be extremely tired, 0 volts. They're going to make it home, but they're done. They're going to bed. It's over. So they still get there. And so that's the difference between current and voltage. Current and voltage is just that they are going. Voltage is how much energy are they carrying with them while they're going there. So if they're in series, they're all going on the same path. They're all driving the exact same road, the exact same way, and they're all tired by the time they get home. So if they're in series, they will always have the same current. And that's a really common idea. And it's based on the junction rule. Remember I said, is however much splits off is how much comes back together. And if there's no split, it's the same the whole time. This is a pretty common conceptual question. They'll try to make it sound like it's different, but it's the idea, it's in series, it's the same. So what if the 9 volts came back? Is that how short circuits are called? Yes, kind of. It's more like, here's how you short a circuit. If I wanted to short a circuit, I give it a path of no resistance. And so basically, this is your traffic, these are your stoplights, these are slowing the electrons down so they just don't go crazy out of control. If you give them essentially a freeway with no rules, they're going to go out of control. Out of control for an electron means it's going to go really fast, get extremely hot, and start to burn something. And so that's why you don't want to short a circuit, because that's how you cause fires. Electrical fires come from shorted circuits. Whether that's because, something wasn't connected right, something actually touched, or whenever you see those huge bolts of lightning in YouTube videos come from your transformers or the lines, you've shorted a circuit. You gave it a different way to go that has very little resistance, and it's going to go there extremely quickly. Yes, just said the answer to the first one is officially, they will, if they're in series to each other, they're going to have the same current. So right here, if I short it, I put a wire here. That means that they have the choice of going through stoplights or going on the freeway. They're going to go through the freeway, but they're going to drive fast and reckless and cause a fire, basically. And so, because those 9 volts have to go somewhere, because the home for the electrons do not want to let anyone in who's still excited. They're like, no. You only come home when you're good and tired. So no excited electrons make it back. Eduardo, be nice or I'll lock you out. So that's what's going on here. So the current's the same. The amount that came in go out, and they spend their energy. If you give them a path where they don't spend energy very easily, they'll go out of control, crash, and burn. And then none of them are going to take the hard path, because why would you if you were given an easy path that you can go fast on? So, and so that's kind of the main idea here. And so then based on that, which one's going to receive more voltage? And so the way to think about this is that V equals IR. Voltage equals current times the resistance. So I'm not going to get into this too much, but this is, say, when it asks you to predict the current, I don't want you to measure it. By predict, I mean the current And so the voltage is going to be whatever you guessed it to be. So you can leave this as a fraction. That's completely fine. And so the voltage is going to be your prediction. The resistance is going to be the actual resistance of the resistor. So you don't need to predict the resistance. That's fine. You just write down the resistance. And again, I'll be checking your mind and providing feedback. So that's pretty much all I wanted to cover today, to just kind of go over this. Again, we'll try Zoom tomorrow and go over some practice problems to hopefully give you more conceptual understanding of this. But that is the main idea here. Predict your answer these questions, predict your voltages, write down your resistance, and your current is going to be voltage over resistance. If you're using the same battery, is the voltage constant? Great question. Theoretically, it depends. If your battery is dying, your voltage will keep going down because it's like, I'm trying, I can't do this anymore. If you have a fresh battery, you should have a fresh battery. It should be close to 9 volts. A lot of them actually start off at 10 volts. They try to power them up a little more than they are originally so that they last longer. So it should be the voltage. So TLDR, the voltage should be constant as long as you're not doing it over an extremely long period of time. If it dies within 5 seconds, that's a dead battery. You just need a new battery. So yes, the current and the resistance are inversely proportional, which makes sense. The more resistance, the more stoplights, the less flow of traffic you're going to have from your electrons. So they are absolutely inversely proportional. So again, current and resistance. Current is just going to be a fraction. Voltage is your prediction. The actual resistance is the resistance that you got from your resistors. Oh, and oops, one more thing. Really sorry. So for the total circuit, I'm going to write it up here so you guys can see it. So I'm going to just make up some numbers really quick. So for your resistance, I would like it in kilo ohms. And so that means if I have 1,000 ohms, great, I just write 1 kilo ohm. If I have 1,500 ohms, I'm going to write it as 1.5 kilo ohms. Those are the ones I physically have. Let's say I have 1 million ohms. That's going to be 1,000 kilo ohms, so 1,000 times larger than the 1 kilo. What's the thing next to the K? Oh, yeah, Catalina, I'll hopefully be doing the chart right now. So the thing next to the K, this is the variable for resistance. It's said ohm. It is spelled O-H-M. It's an upside down horseshoe is what it is. So kilo ohm. Current is measured in amps, and I'd like you guys to measure it in milliamps. That's just standard. If you're getting full numbered amps, things are going crazy. Like if you're getting like 2 amps, that's extremely high current. It's extremely unrealistic and actually very dangerous. And voltage will just be measured with voltage. So to make that simple. So first, fill in your resistances to fill out this chart, because your resistances should be given. It's just whatever resistors you're using. There's no guesswork there. It's just write them in. For the total resistance, the great news is For series and series only, we'll get into parallel at a later date. For series, you just add them, which is nice. It's easy. It's just this one, then this one, you add them up. So 1 plus 1,000 gets us, come on people, well, especially if you have a keyboard, type it out. 1,000 plus 1 gives us, waiting on like 2 or 3 answers. 1,000 plus 1. Thank you guys. All right, yeah, it's just 1,001. That was just a life check, checking we're live. Ooh, and that I can write things correctly. So it's just 1,001 kilo ohms. And so your voltage is you want to guess. So looking back at our comments, I think some people said that, haha, Josethi, seriously though, work on your mental math. It's very helpful. So some people said the larger one or the smaller one. And so this is where you guess it. This is your guess. Again, the total voltage is your battery, which theoretically is 9 volts. Realistically, probably not. Like mine was at 8.10. So, and that's okay. And so your current here would be 9 volts, or I equals V over R. So it'd be 9 volts over 1,001 kilo ohms. Feel free to leave it as a fraction. If you can reduce, but you're welcome to leave it as a fraction. Please do not leave these as fractions. I don't know why you would, but don't. Your voltage then, you want to guess. So if you think they're going to be equal, whatever, give me 2 random numbers that we want. So what number do you want me to put in for the larger R? So you can make your own prediction. I'm just going to have you guys make a prediction for me. What do we think? How much voltage should the larger resistor take? 420. Cool. 5 sounds a little more realistic, so I'm going to go with that. Probably not going to use 420. And so I'll use 4 for my smaller one. So it looks like we're going with a 5-4 split. That's fine. Doesn't really matter what you pick here. And then your current would therefore look like 5 over 1 kilo ohm. You can simplify this if you want. Not a whole lot though. So, and this one will look like 5 volts over 1,000 kilo ohms. So that's all you're doing here. Please leave this as a fraction. You do not need a calculator. You can just do this. So from here, that would be done, and then you just test your voltages. So once you test your voltages, you'll get some number in them. I'm not going to test it for you guys, but can I get an F in the chat? Not really sure what that would mean. I'm very much really not grading you guys at this point. I'm just trying to check how you're doing. But so this would be here. And then once you predict, you'll notice there's not a spot for the current. I don't really want you to worry about measuring the current. Your resistors, they don't need to change. They're technically not perfect, but they're normally extremely close. So feel free to leave them as they were. As they get more complex, there are definitely ways to check this, what your total resistance are when we get more complicated. larger total. And so then you're going to actually measure it. So I would expect when you measure your actual battery, depending on how new it is. So for example, mine was actually 8.1 volts. And then you're going to get some numbers in here from your measurement. What I would like you to do to check yourself is use these, your division, the voltage divided by resistance, this voltage divided by this resistance, to check, did they have close to the same current? Obviously, depending on where you round these, because these are most likely going to come up as decimals, just because nothing's exactly perfect, just like my voltage isn't, check, did you get close? Can you use those resistors numbers for everything? Yeah, pretty much. You're going to be using the same 3 resistors this whole time is sort of the goal. Shoot, Ashley, I think I was supposed to give you 4 resistors and I only gave you 3. So maybe I'll be visiting your house again. So for this, you're going to be using the same resistors. We're just going to be putting them in different orders and different amounts so that you will get different answers. What final project are you talking about, Navi? Alex, as far as the numbers I picked, yeah, so those could be right, those could be wrong. I haven't thought about it at all. I mean, honest, it's not entirely a coincidence that I got up to 9, but you don't need to worry too much about that now. I would definitely read your fact sheet for additional help on this. It's a really great source. I actually use the fact sheet exactly how it is when I teach circuits to regular physics. Why does it keep reading 0? Is your battery actually connected, Ashley? Because if there's no battery connected, it's going to read nothing. Navi, I'm not entirely sure where we build a contraption. Well, we're not going to worry too much about things that haven't happened yet. Theoretically, we're back in school. I already have thoughts of how we could change and do a slightly different final project for you guys. That's a little less of a build project, but hopefully is more interesting than just a research report. I'm working on it, to be decided. So your battery's connected. It works when you touch the smaller one. Oh, depends how different they are. So, Ashley, how much voltage are you getting out of your smaller resistor? And Catalina, yeah, I'll post it. I'll post in the old one, but mostly I'll probably make the new ones and then start posting things in both to start and then switch to only the new one. Yeah. So Ashley, basically what you're getting is your tiny one. And I actually think you got them flipped. I think you are measuring the larger one, not the smaller one. Just based on my knowledge of circuits. So you're getting 9.5 out of your, I'm assuming, larger resistor, if everything measurements are right. This, Simon, stop. I'll do both, Alex. I definitely brought some of my copies home. So just because it's the tiny one does not mean it actually has less resistance. It most likely has a huge amount of resistance. So much so that it uses up all the volts. And so Ashley, what's probably happening to you is your larger one is taking up so much voltage that the other one is taking up so little. It's not actually your thing is not sensitive to read it, which is fine. That just means they're going to be very, you can round it to 0. So I'm assuming whatever one you got out of your total battery is probably also about 9.5. And that's fine. And that's actually kind of what I would expect. I'll try to build, just I think we haven't even started circuits. Will we build more complex circuits slightly? We're going to do a couple series, then we're going to do a couple parallel, and then we're going to do series and parallel. Larger one is reading at a smaller voltage. You may have mixed up which one is which. So don't worry about the physical size of them. It has nothing to do with their resistance. But I have a feeling you are reading them slightly wrong. What larger one? The one with the larger resistance, Josetti. People are measuring their stuff right now. Um, okay, so I'm going to write some recommendations as far as I need to put the SDL sheets on the Google Classroom, add it to the Santa list, write a Santa list, and then yes, just at the resistors. And then I'm gonna go through. Feel free to send me pictures of resistors. I'll let you know. Um, and I'll try to do for people I'm doing the um, handing out resistors and other gifts for. I'll try to type out all of the different resistors on them, so you don't have to do guess ones. Oh, sorry, Eduardo. I'm not sure how I missed that. So are we doing the second one from tomorrow? No. Okay, so don't worry about doing the second one tomorrow. If you feel like you've got it, go for it. But I actually really want you guys to check in with me at each page, which I know is going to be a pain for both you and me, honestly. Um, but hopefully over Zoom, I can see your guys' stuff so I can check how we're doing on each thing. I would really like you not to move on until you're sure you got your measurements right. Um, just because I want to make sure we are measuring right, because that could set up your entire path wrong if we're measuring wrong from the get go. So go ahead, complete this page, really think about it. Feel free to do some research, try to figure it out. I will be back tomorrow trying out Zoom. And I will make the new, right now, yeah, I'm doing a live for regular at 5. So right now I'll start up the new web page. I'll send you guys links on Google Classroom on how to sign up, and I'll start posting all the new stuff into there, including a place to submit your SDLs by either taking a picture or writing it directly into the web page. So either one will work. So how do you know the difference between the larger? You have to read the resistors. So I'm pretty sure you have 1 million and a 1,000, so it's 100 times more. Yes, regular physics. They also are doing lessons. Um, so can you turn in all the late work today? Make sure you go and turn it in about the right way. You have to email it to me with the subheading late. I will probably grade those over the weekend, and what I'll do in my email is I'll just search up the word late, and so it'll pop up directly. What if you can't read them? If you can't read them, you're going to send me a very good picture on Remind. Make sure it's in full light, preferably bright daylight, because it's sunny outside. Go outside, take a nice picture of it on a clean surface, and I will do my best to read them for you and get back to you by the end of today. So that should hopefully give you time to at least try to test it out by tomorrow morning. Okay, so again, final closing things. 1, work on this. Try to read resistors. Feel free to use the resistor reading page to help you with it. 2nd, go over the fact sheets. I will post more fact sheets. 3rd, there is a quiz today. It is due by 8 p.m. Yeah, Jocelyn, I'm just going to go over. Are there any problem sets? There is that problem set 10 that I want due by tomorrow. Because again, this weekend, I'm going to try to settle out that old Google Classroom and move on to the next one. It's just one problem. I'm going to reduce the amount of problem sets I'm giving you, but I'm still going to give you problems because I need to know where we're at. They're going to start doing circuits as well as review ones. The AP quiz thing says it opens tomorrow. Interesting. Never mind. I guess the quiz is tomorrow. Don't worry about it. Do it tomorrow. Let us see the dogs. Diana, you awake? Come here. Kitty. Diana, come here. It says 10 a.m. tomorrow. All right, Alana, then apparently that's how it's going to work. 10 a.m. tomorrow, it'll be open. So do the quiz tomorrow, work on labs today. A lot of people have turned in their Wave Lab on Pivot Interactives. Plants, I can show you some plants, but I don't think you quite understand how many plants there are. So here, this is my Jade Sansevieria. It's not fake, it just kind of looks like it. This is my Sansevieria cylindrica, named because it's like a cylinder. They're the same type of plants. I can't open the pivot thing. Make sure you sign in and make an account. If you want, again, send me screenshots of the process. What about the late work you're supposed to turn in on Google Classroom? On Google Classroom, you're going to still submit whatever documents to me via the email, because going back and getting late documents on Google Classroom is probably one of the most annoying things I've ever had to grade. So as far as late things from this week, I'll still go check on Google Classroom because there's no physical way for you to turn it in. Anything from before our week of absence, email it to me like Alana has. All right, Diana, come here. Didi, where are you going? Come here. All right. Yes, send me pictures of the video notes. Send the docs on Gmail as well. Yes. Yeah, good girl. And then this one gets her own couch right now because she's being selfish. All right. So I'm actually going to go take them on a walk. Oh, there's another plant. And then it's kind of bright. There are some of my outdoor plants. So we can do a plant collection thing another time. Most of them are upstairs, and the hubby absolutely does not want to be on camera. So we'll do that at another time. So I will talk to you guys later. Feel free to send me your reminds or things on Google Classroom, and I'll try to get things set up so we can get more organized and make it easier on you all in the future. All right, have a good day, guys.